Section 8.3 is all about compound inequalities. It's basically taking two inequalities and putting an and or an or in between them. Now, a compound inequality basically says that you have to satisfy either one or both of these inequalities. So here it says that it says that -5 is less than x, and x is less than or equal to 2. So we have these two different stipulations, and what we're trying to do is we're trying to find what values of x are going to satisfy both of these inequalities, this and this. So one way to do this is to look on a number line. So that's what I'm going to do. I'm just going to draw in a number line here. The only two numbers that I'm really concerned about are our two boundary numbers, and I consider these to be our boundary numbers. That's the terminology I'll use. And the one thing that we need to make sure is we need to make sure that wherever we put them, they need to be in the correct relationship to each other. For instance, we know that -5 is below or to the left of 2, so we need -5 to be on the left and 2 to be on the right. What I'm going to do is I'm going to graph this. I'm going to try to use some colors, and I hope that they show up on here. First, I'm going to graph this inequality. -5 is less than x. So what we want to think of is, how does this relate to the x? Right? What values on our number line are going to satisfy this inequality? So we're saying -5 is less than x. So what kind of values are going to satisfy this? And we can sort of just plug in some values to either the left of -5 or to the right of -5. If we plug in to the left of -5, that's like -10. So -5 is less than -10. Is that a true or false statement? It's a false statement, right? -5 is definitely greater than -10. So we know that we're not going to shade over here to the left. Now let's try a number to the right of -5, and that would be 0. So -5 is less than 0. Is that a true statement? Yes, that is a true statement. We could even try larger numbers like 20. -5 is less than 20. That's a true statement. So we know that we would be shading everything to the right of -5 for that first inequality. Oh, excuse me. Okay. Now the next thing we need to do is we're going to have something at the actual boundary value. And whenever we have either a less than or a greater than sign, and I'm going to put this just as a little note in the corner, if we have a less than or a greater than sign, we're going to use parentheses in order to signify these inequality symbols. If we have a less than or equal to sign, a greater than or equal to sign, we're going to use brackets to represent those. For those of you who learned this in high school, the parenthesis is similar to an open circle, whereas the bracket is similar to a closed circle. If you know what that means, that's great. If you don't worry about it. We're going to be using parentheses and brackets. So here we have less than, right? Not less than or equal to. So we just have less than. So that means we're going to put a parentheses at -5, and we're going to open it in the direction that we shade. There we go, lots and lots of shading. Now what we can do is graph our second inequality here. X is less than or equal to 2. Can we see that blue-ish color? So what values of x would satisfy this inequality? We know the boundary value is 2. Basically we're looking for above 2 or below 2, right? X is less than or equal to 2. So less than is below. We can also double check that by plugging in some numbers. Maybe 0. 0 is less than or equal to 2. That's true. -100. -100 is definitely less than or equal to 2. So we're going to go ahead and shade to the left for this region. There. And because this is less than or equal to, we're going to have a bracket, and we're going to open in the direction that we're shading. So our bracket is going to open to the left. Now, although this does represent each of these individual inequalities, since we're doing a compound inequality, we're dealing with and. So we're saying this has to be true and this has to be true. We want to be able to sum up that situation using this graph. So in what region to the left of -5, in the middle between -5 and 2, or to the right of 2, right? So the left side, the middle, or the right side, what region will this and that be true? And that's where both of them are shaded, where it's shaded in both pink and blue, and that's going to be in the center. So in the center, I'm going to darken it in black pen because that's our overall answer that we're working with. Ooh, we have a lot of shading going on here. Shading, 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 shading. Now another way to represent this, because there's this overlap, is we can actually represent it using a three-part inequality. And a three-part inequality is just saying your lower boundary, here is -5, your upper boundary, 2, you're comparing x is in the middle, and next to the 5 we have less than, next to the, between the x and the 2 we have less than or equal to, because of that there. So this is another way to represent this. When we see a three-part inequality, we know that we're only going to be shading in the center.